Can everyone see me so far? Is it working? No? Yes? Can you guys see me? Yeah? Okay, awesome. Okay, so yeah, once again, sorry for the technical difficulties. The projector is not currently turning on, so this is our solution for now, but hopefully it'll get fixed later if somebody comes and helps. So today we are doing the Python data visualization workshop. This is UTD GDSE, so here we go. I'm the presenter. I'm Nicholas Zoltan. All right, so today we're going to be going over how we gather data, gathering a bit more if you guys want to add to that, and then talking about interactive Python notebooks, which are extremely useful for just data visualization in general, but Python as a whole, and talking about Seaborn, which is a Python data visualization library, and then we'll be doing some hands-on data visualization with the collected data we've gathered and having any questions. So first, if you guys haven't already, I create a form. It has a bunch of anonymous questions. Feel free to answer it, and we will be using the data that you answer with in the actual visualization. So I will be updating the data. I will be sharing a GitHub repo later in the slides, and you'll be able to actually pull that and do the visualization yourself as well, along with me. So I'll give you guys a couple minutes to do that if you would like.
Since we are virtual in person, I could just send the link directly to.
Oh yeah, there you go. Since we're sending the link, I will go on. All right.
Oh, I sent it in the Discord, not the live stream.
All right. So while you guys are going through that, I will be updating the data on the repo, like I said, later. So feel free to continue with the form, and I will just start going on to the next part since we lost a little bit of time, but not too much. So interactive Python notebooks are an amazing feature that comes with pretty much every single IDE that uses Python. And a lot of people don't know about them unless they've done these specific projects before, but this is not the only thing they're applicable for. They're actually useful for a whole lot of different projects and are really great for when you have a ton of data or a really long startup time for a program. So what they actually are is it essentially runs the server locally and maintains the variables, but you can run your code in chunks at a time. And essentially you're able to modify your earlier code and rerun it before you execute later code. And we'll see how that works a little later, but it is extremely useful for some of these things. So the Python library that we're going to be using today is Seaborn. Seaborn it's actually based on matplotlib. It uses a lot of matplotlib as its backend, and you can even use matplotlib to modify the Seaborn graphs and vice versa to some extent. But the reason we are using Seaborn is because it is very easy to start with and makes very pretty graphs. And on top of that, Seaborn as a whole is made to be slightly less stateful than matplotlib. And what I mean by that is matplotlib, you create a plot and then you use that plot later on, but it's hard to recreate the plot without messing with global variables to some extent. Seaborn actually does change that and allows you to just run functions to create these graphs in real time whenever you want. So why is data visualization important, and when might you guys use this? Data visualization is used in all kinds of industries. For almost every company, there's some form of big data they're collecting, especially nowadays. So it's notably, I've talked to some people that do like oil and gas and have used tools like this to actually do their work and formulate ideas and products based on this data. So even if you aren't going into a data analytics field, this is still a very useful skill to have, and honestly a fun one if you guys ever want to do projects about this. So now I'm going to ask that you guys, if you want to follow along, actually clone this repo. And I'll put this link in the chat, and I will update the data that we're actually going to be using while now that you guys have had time to fill it out. So I will be actually updating the repo in just a second. And we will look at some of the graphs we can make and uses for all of this as a whole. So all I'm doing is I have a Google form that's linked to the spreadsheet. I'm downloading it as a CSV, and we'll actually be using this in the workshop. So I'm going to just take it and then go to the GDSC workshop, replace the file, and then we will merge that change. And you guys should be able to actually download the data through the repo. So I'll give you guys a second to catch up there. I know there's a lot very fast, but let me know, or yeah, I'll just wait a couple minutes and give you guys time to set up the repo and pull it and all that. Yes. Yeah, I just put in the stream, I think. Can you guys see it? No? Okay. Then I'll put in the Discord and the link to my repo so they can clone it and then follow along.
Okay. I got it. I can just post it in the live stream.
Awesome. All right, then I will let you do that.
Post the GitHub.
While we're waiting for all that, does anyone have any questions yet? Is there anything you want to ask about?
Where's the link? I posted in the Discord.
It's probably because of the cold weather. Texas just breaks, you know? Also, on the repo in the README, I did put sort of instructions for how to set up a virtual environment or just install the dependencies. Using pip, I do have requirements.txt, and the command is there if you need it. But of course, you do not have to make a virtual environment. It's just sometimes good practice because when you pip install a bunch of things, it can bog down the overall interpreter for your system. So sometimes it's helpful. Is everyone getting the cloning okay? Is anyone still working? Okay. Yeah.
Which channel is the link in?
General, also announcements.
For the Git repo?
Oh, the GitHub repo link is on the live stream. I could post it in the Discord too.
Oh, okay.
Yep, the GitHub link is Google form, everything is there.
Also, once you've cloned the repo and you have it locally, feel free to run the first cell by hovering over it and clicking the play button on the left for VS Code or something similar in PyCharm, Jupyter. They'll all be about the same. But feel free to run the first cell. It's importing it, so it'll let you know if there's anything major wrong with the packages. All right, how's everybody doing now? Anybody still have any issues? I know we have a couple people around here that could probably help. If you do need anything, just let us know. I'm going to take that as everybody's doing great. All right, so once you've downloaded the repo, cloned it, I want you to, after you do the pip requirements, I want you to go ahead and run the first cell so we can make sure everything's working great and actually import the libraries that we're going to use. So as we can see here, mine is running now. And there we go. 4 seconds to import everything. So now what we have just done is actually import all the dependencies and load them into our local server that's hosting this interactive Python notebook. So hopefully we'll get the projector fixed momentarily, but I will continue. So the next cell is doing a couple things. First, it is actually loading the data into our Python server as a pandas data frame. Are we still good? Yeah. Okay.
Is the stream still going on? Yeah. Okay, keep going.
Awesome. Okay, so we're actually loading it all in as a data frame through pandas. And normally you won't see these things named like this. You'll usually say as PD, which stands for pandas, and Seaborn will be SNS, stuff like that. But in reality, all I'm doing is explicitly declaring the imports using their full name, so it's very easy to follow. So what we're doing here is we are actually loading in all the data, and these subsequent lines are a couple things. Primarily, it's me replacing data with numerical values, because when you submit the form, a lot of what you submit is essentially strings. And we can't really say a numeric value for like freshman or sophomore without explicitly declaring it. So when we have these dictionaries here, like GPA dictionary, we're actually replacing the column in the data frame using data.replace and setting it all the values in there equal to the explicit values in the dictionary. And we're doing a couple of these at once because data.replace actually takes a dictionary and then replaces all the values with the matching column and value. But yeah, so that's why we have 4 different replace lines. We're just defining it so you can see it all in one line for the most part. I know some of these are quite long. And then down here, we are actually filling all the non-applicable values. So if you skipped any questions or submitted something that was incorrect input for the given question, some of them may have let you. If they did, it is now setting that to 0 for these numeric columns. And by saying, yay! All right, awesome. Thank you.
No problem. When you're done, if you can power it off, so it can resync it together. Because right now it's not turning on.
Oh, gotcha.
Yeah.
Thank you. All right, guys, big round of applause for them. All right, so back to here. Okay, so, and as a fun little feature of our interactive Python notebook, we can actually just say data and it'll hand it over to Pandas, which knows we are in a interactive Python notebook and gives us this beautiful display of our data frame without us having to do anything. So we can see just a quick overview of our data. We have 25 responses in the CSV and actually 26 lines, but the first line is the headers. So down here, what I did is actually transferred all of the numeric data, so stuff we can put a number to. So things like color or like favorite color was on there. I can't really give a number to your favorite color, and especially not every color everyone can input, because things like capital letters could be important for some data sets, is not for ours, but it does affect actually mapping the values to numeric. And yeah, once again, I can't really rank your colors, though, you know, green is the best. So if we run this, we can actually, that's what we're doing here. And as we can see now, the data frame that shows when we actually call numeric subdata is one that entirely, or hopefully, contains only numeric values. So this will allow us to do a couple more things with this subset of the data, and we will be sort of switching between them using the main data frame to do graphs with the labels on them, and using this one to do graphs without the labels and for things that are special to numeric data sets. So running the next one, what we're doing here is actually creating a heat map. If you guys have taken statistics, all this is it's essentially trying to fit the data to each other. So using, I believe, like just regression, but essentially, if the data is correlating, we're going to see a very bright value, just like this legend. And then if they are extremely uncorrelated, we'll see a really dark value, like this. So as we can see, each individual question correlates with itself 1-to-1, which is great. And then we can also see, using these individual squares, which other things have correlations. And the reason I did this is so that we can see sort of which questions we'll want to correlate, different things we can see in the actual data. So as you can see here, stuff like how many credit hours you're taking and which year you've been in are oppositely correlated. So it seems that people don't like taking harder credit hours when their previous courses were really difficult, which makes sense. So now moving on down, we will actually be making our first very explicitly defined plot. So up here, we were just giving it a data frame with correlating values, which is a feature of Pandas and Seaborn, but we're not actually defining the X, Y, or colors. So down here, what we will actually be doing is defining the X and Y for a scatter plot. So if we run this one here, we can actually see how many programming languages you know versus how many events you've attended. Does not seem to be correlated, but we can actually see here that we do have a figure. It's on there, and Seaborn's handling all that, which is great. So it means everything's working, and we are able to make graphs based on our data. So I have a couple more example graphs, and then if you guys want, we will go through and you guys can let me know which graphs you want to see. We'll try and make them. And we'll go over a little bit more of the colors as we go. So, because that's a great feature of Seaborn. So here's another one that I had fun with. Are you in a relationship versus how many credit hours you're taking? And as we can see, the average for people who are not in a relationship is higher. It was actually reversed earlier, which was extremely interesting. But because we have more data, there's a bigger spread. Yes, what's up?
Which one is yes and which one is no for our relationship?
1 is yes and 0 is no. That was because we mapped the data earlier, and I'm just using those so that the graph's a little less cluttered. But yeah, so as you can see, we're able to make 2 box plots automatically because we have 2 values in the are you in a relationship question. If we had more, it would actually create more box plots for us. And the y has to be somewhat unique. It has to be numeric. So yeah, the y value is actually mapping to just 1-to-1. Every single one will have the same y, which is a great feature of box plots. So this could be used for something like seeing the GPA distribution for like year or something. And a company might use this for trying to determine reliable data versus the mean, or even just seeing the median between 2 data sets. If I remember correctly, that bar in the middle of the boxes is actually the median of the data. So we can see that the median is lower for 1, but higher for no. But as we can see, the upper quadrant of people in relationships take higher credit hours than people who are not. So it's an interesting little tidbit for you. Do we have any questions so far? Awesome.
Can you just
Okay.
go back up 1 second?
Sure.
That's funny. Okay, you can move on.
All right. So another one I thought would be interesting is what is your GPA versus what type of professor is your favorite? And what we're actually doing here is using a histogram. So the X value is your GPA. And as when you entered the GPA into the thing, since I didn't want to make it too personal, these were wide ranges. So above, we actually mapped those ranges into essentially their middle values. So 3.5 to 4 became 3.8. So that's why they're in categories like this. But interestingly enough, and so these bars are the hue is which type of professor and the X value is GPA. And so the legend is actually telling us that hue value so that we can see that correlation, even though it is a box plot. And normally you wouldn't see this type of correlation using a histogram, sorry, not box plot. So as we can see, people who like easy professors make up the extremes, and these bars are the people who are, excuse me. So when we are making these, because I mapped them to numeric values, they can get weird, and I have not had tons of time to test these. So we will see colors that I'm not exactly sure what they mean at this moment. If you want, feel free to look into it. Yes.
Did you pick the colors?
I did not, but you can. And we will see that, I believe, a little bit later. But yeah, that's a great feature of Seaborn. You can pick a ton of the color ranges and stuff and make them really pretty. But yeah, as we can see, people who are here, I guess, at the GDSC social or responded to it do tend towards a higher GPA. So tell your friends, I guess.
Wait, was this a correlation?
This is a histogram. So it's just showing the count of values. So for example, we have at least 8 people, probably 9, who have 3.8 or 3.5 to 4, who responded to the survey, and then 4-ish for the 3.5 range. Yeah. All right. So, oh yeah, what's up?
We don't know what the gray box is.
Yeah, I'm not sure at this moment in time. I'm-
People who didn't answer.
Yeah, it might be. I'm not 100% sure, but that would have been my guess too. So here's another one we have. This is a scatter plot using hue. And so what we can actually see here is how many programming languages you know versus how many GDSC events you've attended. And the hue is how many hours per week you study. So here we can actually see 3 points or 3 aspects of the data, even though it's a scatter plot and it's 2D. So in reality, you would normally only see 2, but we're seeing a third. And this is really important for some statistical trends, like for example, height versus sex versus weight, stuff like this. Even sometimes there's a third trend hidden in the data, and using hue like this with a scatter plot can reveal that third trend even in data that's seemingly not correlated at all. For example, with like sex versus height, you can see that like one sex is generally taller, but if you're just doing height and weight, you wouldn't see that like sex matters for that, for example. So this is an extremely useful feature of Seaborn, using that hue, and it allows us to really bring out more trends in the data than we would normally see. So here's another one. It's how many hours per week you tend to study versus your GPA. And then the hue is actually how many credit hours you're taking. So here we have a lot of people who have 3.5 to 4.0s are taking, or yeah, okay. So a lot of people who have high GPAs tend to actually study less. I don't know what you guys are on, but that's great. So, and also we can see that people who have high GPAs, it almost looks like they are taking less credit hours, but it's kind of hard to tell because some of the people, yeah, or sorry, yeah, the reverse. People who have high GPAs are taking more credit hours, which could mean that full-time students are able to commit more time to it, for example. We would have to look at more data to like really understand these trends, and we only have 25 responses, so some of these may not show any accurate trends at all. But if we had like 5,000, this might give us a really good idea of what's happening. So another one here is, what is the average number of hours you sleep each night versus your GPA? And the hue will be how many credit hours you're taking. So it looks like we have an exactly even distribution of people who have high GPAs and sleep. So it looks like sleep has nothing to do with your GPA, according to this. But it does sort of look like the people who have the most credit hours they're taking are sleeping more, which is great. Yeah, good on you guys.
Wait, what? Hang on. So the dark one is 18 hours?
Yes. And the darker it gets, the more credit hours you're taking.
Legend is covering some of that.
Oh.
Yeah, there are a couple down there. People who are taking a few credit hours are sleeping in just random amounts, which is good. But it is kind of interesting that the more credit hours, or some of the highest credit hours, tend to be sleeping pretty evenly. It's great. And so the reason we're not seeing tons of data points here, or 25 to be exact, is because a lot of you must have chosen whole numbers, which makes sense considering we're humans and we like whole numbers. And so these points are overlapping, and that's why we only see a couple. But once again, for different data sets, you'd probably be able to see a lot more of this range as opposed to like a grid sort of like we see here. And so the last one I set up is which type of professor you prefer versus how many credit hours you're taking. And this is actually a cat plot, which I've not personally looked into what a cat plot does, but we can sort of see a general. From what I understand, it's some form of a scatter plot. It shows us a little better the overlapping data points. They're not aligned perfectly, even though they are the same response, for example. And up here, you can actually see it says easy and hard because I remapped the easy but you don't learn as much and hard but you don't learn a lot to easy, hard, and no response instead of 0. And actually, if we comment this out and then rerun it, you guys will see why. It overlaps because we have really long names for everything because they are questions. So moving that back, we will actually have the cat plot we like again. So people with easy or people who prefer easier professors seem to be taking more credit hours on average or in general than people who prefer hard, which I would say makes sense. I personally wouldn't like a lot of hard professors and a lot of credit hours. That would be crazy. So yeah, there we go. We can see a good correlation there in our data. And I did make this repository public and it will stay public. So if you guys want at any point, feel free to make graphs using this data and try to spot trends or have your friends take it and let me know and I'll try and update the data on the repo. But is there any other graphs you guys would like to try and see? Anything you would want to visualize?
I have a request.
Sure, what's up?
Correlation between number of GDSC events attended and GPA.
Okay, all right. So to do that, I'm going to use the numeric subdata because I made sure that everything was numbers in there. So for that, you said, or x equals numeric subdata, and that'll be one other really great thing about this is it actually does autofill the questions in VS Code at least, which is amazing because this is a variable and we, imported it earlier, but it is actually grabbing the values for the columns from that variable in real time. So if we were able to, or if we went back and changed the data set to add more questions, for example, it would autocomplete those questions too because we're in interactive Python notebook, which is awesome. So how many GDSC events you've attended versus your GPA? Y equals, all right, so GPA. There you go. What plot would you like it in? Do you have a
What do you
preference?
recommend? I
Um,
just want to see.
maybe a box plot? I don't know. A scatter plot? Okay. So we can just do that by calling seaborn.scatterplot and setting x equal to x, y equals y. It's not good practice to name it like this, but it does work. So save that and run it. There we go. So,
And 10 GDSC events.
There you go. Wow, some people who have attended 0 before have low and high GPAs, which is good. Oh, and you know what? The low GPAs, if you didn't input GPA, then it's probably mapping to 0. So that might be why we see some like really low GPAs in some instances. I don't think we've seen a 0 yet, but if we do see a 0, that's what that is. And when we actually import the data frame, I mapped freshman to just like an average 3.5 because since freshmen don't have a GPA yet, or I don't think freshmen have a GPA yet, I wanted to try and visualize the data as like a sort of average. I don't know the average GPA for CS students, but I figured that would be a fair place to put it in since the early responses were like super heavy on the top end. So yeah. And Niranjan, would you like a hue added to this?
I like blue. Blue's perfect. Does
Blue.
anyone else have a color request?
Any other question you wanted to try and visualize in this data? What's up? Yeah, absolutely. Sleep versus interrelationship. We'll add code. Doesn't like me adding code right now, so you know what? We'll just change this one. Sleep how many hours do you sleep versus in a relationship? What plot would you like this in? Okay, I'm kind of feeling a bar plot. And we're actually going to make that the why then, if that's the case. So, because are you in a relationship is going to be a yes or no question. We're going to want the box plot to use that as the how many box plots we have. So we'll only have two, hopefully. Yeah, and there we go. So we have one outlier. So whoever sleeps the most is not in a relationship. But other than that, it is almost exactly average, which is kind of interesting.
Oh, that's not as shocking as I thought it would be.
I guess significant others aren't invested in you getting more or less sleep, as we can see. What's up? Yeah, so actually, that's a very good point. I forgot that I did not do that. So while we're at it, I'll also show you the documentation for Seaborn. I believe I put in the slides further, but I also put on the repo. So if we actually go to the repo, I believe it's down here. So we have tons of examples. And like these are extremely advanced because Seaborn's amazing and you can do crazy stuff with it. But we don't have thousands of data points. A lot of these are random, but I did want to make it so that you guys were doing it with data that you made. So here we can see using color, we can actually change it. So if we take this, and I believe there's also a palette where you can change it's like predefined. So if we do color, just take that off and get rid of the extra one. Hopefully that will change the color. Oh, I accidentally just deleted it. Yeah, so I use Vim, and Vim is not necessarily the best for this. But as we can see here, now we have green for our plot. And I like this green, yeah. And I believe even if we change something like this with it, it may not be happy because we are changing the color while we have the hue defined. But let's just see. I haven't tried this yet. Cool, it did not change anything. I guess the hue is overriding this one. But yeah, you can actually change the palette as well, which I believe is how you're supposed to do it for hue. But this is working. So yeah, we have a green plot. Are there any other questions you want to see visualized? Is there any interesting plots any of you have found so far or tried?
Found it interesting that people that attend more events have high GPAs.
Attend GDSC events, guys. Give you that 4.0. But yeah, so this is a wonderful feature of the interactive Python notebooks, but also, as you may or may not have noticed, even before I changed any of the code, it did change the actual file for the repo. And that is because if we were to save it, it would save the outputs here as well. So if you were sharing this file with somebody and they loaded into their IDE after you had already run the code, they would still see the same outputs that you saw. What's up? So this is actually in the way of it, but you can, I believe, yeah, clear outputs of all cells. I don't know if you can save it without clearing them, at least not with Git, but that is how you would do it if you did want to actually get rid of all the output. And there's also the run all button, which we didn't use earlier because we were stepping through it. But if you did want to rerun everything, you could just press this button and it would go through all of them for you. I know we don't have the B-movie script like the last technical workshop, but I think these are interesting. And we are nearing the time, so well, let's go through a little bit more of what Seaborn's able to do, and then I will let you all go. So yeah, there are a ton of different plots that Seaborn allows for. It does a crazy amount of these, and there's some really advanced ones and some stuff that's used for really neat things in actual industry. Like for example, these facet grids. I don't know what you would use it for, but you can absolutely use it for something. And I know there's like geographic maps and stuff you can make, and all kinds of different ways to visualize the hue and plots I've never heard of before. So if you guys want, this link will be posted in the GitHub and probably also in the stream. I can absolutely do that. But there are a ton of different options. And one neat thing that you guys may encounter, I will see if I can find one real quick before we hop off, because this is an interesting sort of quirk of Seaborn, being that Seaborn is based on Matplotlib. Sometimes we will see Matplotlib imported and actually used. So PLT is over here. And what's happening here is they're actually using Matplotlib to change the size of the graph. And you'll see this in a couple cases with the really advanced graphs, because like I mentioned earlier, Seaborn actually does use Matplotlib on its backend. So even though Seaborn is mainly specialized to do these like really pretty graphs and things, it can't do everything. Like Matplotlib has some like 3D graphs, for example. If anyone's ever seen those, they are crazy. But if you did want to make one, you absolutely could. And Seaborn would totally let you use Matplotlib to do it, and then Seaborn would do something like color it. So in this example, it's still using Seaborn to do the heat map, but Matplotlib is handling the actual size of the figure. So there's just some really interesting quirks and tons of stuff you can do with Seaborn, in case you guys are curious or ever want to look into it. But yeah, other than that, we have a couple minutes left. Are there any other questions? Anything anyone's curious about, wants to see? Anything at all? All right, well, I guess I can let you guys go then. I hope everyone enjoyed this technical workshop. And yeah, this code will be public for you guys. If you ever want to look back at it, I don't foresee ever taking it down, because with student, and I think in general, GitHub gives you unlimited repos. So that's nice. Thank you, GitHub, for that. And make sure to come to our other socials and technical workshops. They're tons of fun. I know we already had our Thanksgiving one this month, but it was a great time. If any of you were there, I know some of you were there because I recognize you. Yeah, we had scavenger hunt and stuff. And I believe our next social's in February. So it'll be a little while. But yeah, it'll be a great time.
There's one thing, there's another GBC, I know they're hosting a virtual Google Cloud at our workshop. I posted the details to that on Discord. It's on Saturday at 9. And it's virtual, so you know.
And some of those, they give you like cloud creds and stuff to use too. Yeah, so if you want to make something with like the official cloud resources, go look that up. And all of them are tons of fun. They're very informative. So yeah, thank you so much for coming, guys. And thank you for doing the form. I really appreciate it. It's fun to see these correlations and things, or lack thereof, surprisingly enough, with GPA and sleep. But yeah. Thank you, guys. All right.
Am I good to end the stream?
Yeah. Thank you.